So today in class we did an experiment where we compared the volume of things like this to the volume of things like this. So we looked at prisms and pyramids. Or maybe you looked at a cylinder and a cone. And we talked about how their volumes relate to each other. So let's actually discuss that now and look at some problems on how those volumes all relate to each other. Okay? So, going to our notes here. Remember, you can always print these notes out. Today in class we found out that the volume of a pyramid or a cone is 1/3 the volume of a prism or cylinder. Now this will always be true as long as the pyramid and the prism have the same base area and height. Okay? When we look at the figures we were dealing with today, when I look at this figure here, this prism, it's a triangular prism. The pyramid that matches it also has the exact same base. In fact, I could take those bases, put them together. They are exactly the same base. So they have the same base area, and then they have the same height. As long as they have the same height and the same base area, this will be 1/3 of this. And that happens for all of them. Again, that's as long as they have the same base area and height. But that leads us to even bigger things. Like if I have two prisms that are congruent, that have congruent base areas and congruent heights, then they will have congruent volumes, even if the bases are different shapes. So we're going to come back to the pyramid and prism thing real quick. Let's take a look at this. Two different shapes. So here I have two completely different shapes. I've got a rectangular prism and a triangular prism. So in my rectangular prism, I see my base is, I'm going to use this piece here as my base. Okay? So that's my base area. And when I go to get that, the base area of that is length times width. So that's 4/3. So that gives me 12. Okay? Which means the volume is 12/8. Because my height of this figure is a height of 8. And 12 times 8 is 96. So there's the volume of this piece. When I look at the triangular prism and look at its base, well, its base is 4/6. That's not the same as 4/3. But what happens when I take the area of that base? Well, half base times height be half of 6 times 4, which is 12. Now I notice that, hey, wait a minute. These base areas are both the same. The height of this is still 8. So my volume is 12/8, which is 96. Because they have the same base area and the same height, they end up having the exact same volume. Okay? So that's just a neat little thing to look at. Again, as long as they have same base area and same height, they will have the same volumes even if they have different shaped bases. We didn't see any of that today because all of our shapes, well, they had different areas to their shapes. Now, let's take a look at this problem. Here, we don't have prisms anymore. We've got a prism and a pyramid. So this problem is different. This was two different prisms. Here we have a prism and a pyramid. So the volume of this prism, if I look at my base, we have 4/3, so that's 12. So the volume is 12/8, and 12/8, there again, I'm using the same numbers a lot, 36 cubic centimeters. Now notice that the base of this is this 4/3, which is also the same as base, 4/3. So the area of this base is also 12. The height of this figure was 8 centimeters, and the height of this is 8 centimeters. Remember, that's a height on the inside. So this volume is 1/3 of 12 by 8. And 1/3 of 96 is 32. So because they had the same base and the same height, this volume is 1/3 of that volume. That's how we get all of these volume formulas for anything like any kind of pyramid or cone. Okay? Speaking of cone, let's try a cone. Again, because I see a cone, I know my volume equals 1/3 area of the base times the height. That's going to work for cones and for pyramids. So my base area is pi r squared. So it's pi, my radius is 2.1, and I square it. Okay, I can see my radius right through here. And my height is going to be right there. Okay, so I got to go to my calculator. 2.1 squared gives me 4.41 pi. So now my volume is 1/3 4.41 pi times 6. So when I multiply all that together, I'm going to end up getting 8.82 pi centimeters cubed. And there's the volume of my cone. So it's really doing exactly what we did. Remember that for volume of pyramids and cones, we need to use the height of solid, not the slant height. What do I mean by slant height? The slant height is here. Okay, that's what's known as the slant height, because it's kind of a way to measure a height, but it's at a slanted. Remember, our altitude, our height, always makes a right angle. So that's what we're looking for. Where does that come into play? Look at them like this. They gave me the slant height of 13, but that's not the height I want. I want that height. Okay, so I've got to remember, oh yeah, this is actually making a small little inside here with my height and my radius, and this piece here create a right triangle. So I can easily go, well, h squared plus 5 squared equals 13 squared. You may even notice that's Pythagorean triplets. That's going to come out to be 12 meters. So now my base area, pi r squared, is pi times 5 squared. 5 is my radius. 25 pi, which means the volume is 1/3. Don't forget that. It's so easy to forget that. Base times height. So that's 1/3, 25 pi times 13. And that's going to come out to, let's see, 13 times 25 divided by 3 comes out to 325 pi over 3 cubic meters. Okay, so that's really all there is. We only have two formulas for volume. We have the volume for prisms, which we said a volume for a prism was just the area of the base times the height. The volume for a cylinder is area of the base times the height, which you could say pi r squared h if you wanted to go there. And then we have the volume for a pyramid, which is nothing more than 1/3 our last one. Which means some people actually write volume of a cone to be 1/3 pi r squared h. Again, if you really want to get down to it though, these are your two main formulas that you need to know. Okay? They're going to work for everything. The key is what shape is the base. Okay? So that's all we've got. I tell you what, at the end of this, I want you to go back to Google Classroom and there will be a quizzes to do. Okay, so work on that quizzes. It's going to give you a few problems to practice these equations. And then tomorrow in class, we'll do some more practice. Okay? Have a great time, and I'll see you later.